friends here in school, my friends at home, we decided, we read our learning target already, we're gonna be doing 2-step problems. I've already told you, that's probably one of the hardest skills third graders have to try and master, but it is important because you'll be doing them in 4th grade and 5th grade and 6th grade and right up through middle school, okay? So, it is one of our hardest skills, but if we break it down, it doesn't have to be that hard. And in today's lesson, we're going to be doing them, we're going to be using all 4 operations. So we might see some addition, we might see some subtraction, we might see some multiplication, and we might see some division, okay? And then what it says is assess the reasonableness of answers. So a lot of times, boys and girls, look up here, please park your markers. So a lot of times, boys and girls, we have a number bond, and let's just say we got chocolate chip cookies, and we got peanut butter cookies, and we have a total of 75 cookies, and some of them are chocolate chip, let's just say 44 are chocolate chip, and we have to decide how many are peanut butter. And a lot of students will look at this and I'll say write a number sentence, and you know what people's knee-jerk reaction is? Their knee-jerk reaction, just because it's easy to say, I'm going to take 75 and I'm going to add 42. And if I add 75 and 42, I'm going to try to do that math in my head. I think I get 117. So you go, oh, my peanut butter cookies must be 117. Well, if we assess the reasonableness of that answer, what that means is it reasonable to think that we could have 117 peanut butter cookies when we only have 75 cookies in total? All right, so that's really another part of growth mindset. You look at your answer and say, you know what? I don't feel very comfortable with this. This doesn't look like it could be right. I only got 75 cookies. How can I possibly have 117 peanut butter? So then you'll stop and you'll say, you know what? I had a misunderstanding. I wonder what I'm really supposed to do with those 2 numbers. It doesn't look like I should add them because that gives me an answer that is not reasonable. What should I do with those numbers, Devon? Yeah, I want to take 75 and I want to subtract 42. And that would give me my number of peanut butter, and I haven't done the math there. Anybody want to do that math for me? So I'm going to do 52, 62, 72, that's 30, plus 3 more, my answer would be 33. Does it seem reasonable that you could have 33 peanut butter and 42 chocolate chip, and that would make 75? So that's what this little assess the reasonableness of answers means, okay? So we're going to do one problem on our personal whiteboards. When you're doing 2-step problems, it's a good idea when you turn your board like this, because you can have it split down the middle, and we'll do our 2 steps on either side of that middle, okay? I'm going to go ahead and put the problem up on the board, and you can read it quietly to yourself. Kevin, would you mind erasing the board for me? So a good student is looking at this problem, they're deciding what we know, what we're wondering about, what our unknown is, what kind of pictures we can draw. So let's read it together, shall we? Okay. Joe has $173 in the bank. You guys can't underline that, but I can. Okay, then he earns the same amount of money each week for 7 weeks. So it's the same amount of money each week for 7 weeks, which is almost 2 months. Okay? And he puts that money in the bank. So he starts out with some money, he earns some, and then he puts that in the bank. Now, after putting that in the bank, he has $208 in the bank. Our unknown is how much money does Joe earn each week? So, have to figure out how much he earns each week. But first, we have to figure something else out. What are you wondering? We know he starts with 173, right? And we know he ends up with 208. So what are you wondering right now? We're going to have to figure out one thing. Kevin.
How much money does
Well, you're close. That's the question, how much he earns each week. But before we can do that, what are we wondering? Boys and girls, can I tell you something? When there's a two-step problem, you don't want to just read this question back. Usually there's something you're wondering before you get to the unknown. So what are you wondering about right now? If you know he has 173, and at the end, he has 208. Brian, what are you wondering?
which money you can?
How much money does he earn? Yeah, you can't figure out how much money he earns each week until you figure out how much money he earns. So let's think about that. How can we draw our picture for that? So he has some money in the bank, he earns some, and he ends up with a total of 208. How could we represent that with a picture, do you think? Somebody besides Ryan. Lily. How about a Park-Park home number bond? Let's try that, boys and girls. So let's go ahead and draw our Park-Park home number bond. I think she might be onto something. And why is it Park-Park home? Let's not put any numbers in there.
So,
This is what he has in the bank, right? And then what happens? He earns some. And then at the end, he has a total of $208. So nice job, Lily. Okay, well, what other thing do we know? And which one of those is our unknown? Nathan, what else do we know?
how much you have?
Yeah, he has 173, so let's go ahead and put that in there. Nice job, bud. He has 173. And then we have to figure out what he earns. So go ahead and write a number sentence. And how about if we use an E for the letter? Let's use a letter for our unknown and use the word E. Letter E for what he earns. So go ahead and write a number sentence to go with your number bond and use E for the unknown. Why didn't you think about that? When you're caught up, I'd love to hear it. Well, I wouldn't skip count, I would count on. I don't know that I would skip count, because skip count means you're gonna count on by the same amount every single time. What number sentence did you write, Kevin?
208 minus 173 equals 107.
Well, no, first we're gonna write equals E for earns. Okay. But nice job, you got the number sentence right. How many people took 208, the total, and subtracted the one part to get E, the other part? Okay. And then you can do the algorithm, you can do mental math. Let's see if you can come up with what he earns. What is that? I think it looks like I got a couple different answers, maybe not. Allie, what'd you get? 85. Did anybody get anything besides 85? Devon, what'd you get? You got 35. How many, okay, anybody get a third answer? What'd you get? 30. So I'm not feeling really good because I got 3 different answers. All right? So you guys can do your algorithm, but guess what Mrs. Reed's gonna do? She's gonna count. She's not gonna skip a number, she's gonna count out, okay? So I'm gonna start with 173, because I'm trying to find the difference between 173 and 28. In other words, boys and girls, I'm trying to find what do I add to 173 to get to 208, right? That's the whole idea of the number line. So I'm gonna start with 173, I'm gonna say, what do I add to that to come up with 208? Well, the very first number I add is going to be a number to get me to a friendly number. So I'm going to add 7. Why did I add 7? What will I get if I think of 173 and I add 7? Tommy, pay attention. Kendall. No, but what will I get? I'm starting at 173 and I'm adding 7. What am I getting? No. It's a number line, guys. Thank you, 180. What am I going to have, class? 180. You guys got to know how to use a number line. We use them all the time. Okay? Now I'm at 180. Then I'm going to say, what am I going to add next? Well, guess what I'm going to add? Because I'm not going to wait for you guys to decide. I know what I want to add. I want to add. Why do I want to add 20, Nathan? That'll be 200. Now I'm at 200 and I want to get to 208. What do I add next, Devon? Yeah. So how much did I jump? I jumped 20. I can put my 7 and 8 together. That's 15. 20 plus 15 is
35.
So who had the right answer? I'm not sure who it was, but Devon, thank you. The correct answer was 35. So, wait. I just want to show you this. I want to show you why. I know I'm going to get on my soapbox, Mrs. Duggan. To show you why I do not like the algorithm. Because people do things with it and they have no idea what they're doing. If I take 208 and I subtract 173, yeah, this is 5. Some people will say, oh, 7 minus 0 is 7. You know why? Because they do not understand the math that is happening with the algorithm. And they do whatever is easy for them. And that's why, yes, you do. You do the top one and then you have done bottom. I have so many kids who cannot do the algorithm correctly because they don't understand how it works. Okay? All right, so we got $35 and that's what he earns. I promise I won't talk about it anymore today. All right, now, he makes the same amount each week for 7 weeks. What's our unknown? How much money does Joe earn each week? What would my next picture be? What do I know? 7 weeks, right? So what could I draw, Devon? Oh, I love it. How many parts will we have, bud? Nice. Oh my goodness. Honest to God, I think I'm going to put you in charge next time I'm out. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. You want 7 parts? You're going to draw 6 lines. Okay, I know the total I earn over those 7 weeks, or that Joe earns rather, is $35. Right? That's what we figured out he earns. Now, how am I going to figure out how much he earns each week? Brian Rathburn, between you and Devon. Did everybody hear what he said? Fair share. Go ahead and do it then. Don't wait for me. Do your fair share. The neater you are, the easier it will be able to. You did fair share, Celia, what did you come up with? 5. How many people got 5? Yep. So what number sentence, this is really important. What number sentence describes what we just did? Don't just look at your picture. Don't just look at your picture, but what number does sentence describe what we just did? Luke. But we don't know 5. What number sentence describes what we just did, Thomas?
5 times.
We don't know
3.
5.
No, 5 times.
We don't know 5, so you can't use 5.
Oh, sorry.
Lily.
35.
There we go. Yeah, except for let's use M for money. Look at the difference between the number sentence that Lily gave me and the number sentence that some other people suggested. Sure, you look at this and you see 7 times 5. But that doesn't describe what we did, does it? What we did is we took $35 and we divided it among 7 weeks. We got M, and now we know M equals 5. The only way I would accept a multiplication sentence for this is if you wrote this. Why will I accept this? Because you showed me that what you were missing was the size of the group. But this is really a division problem, boys and girls. No, girls. Put them down. Okay. Now, can I show you one other strategy? You know, anytime you have a number sentence, look at this in isolation. 35 divided by 7 equals M. Forget about my word problem. What strategy could I use to find M? I only have two students that know what strategy I could use to find M with that number sentence. Eden, what could I do?
You could. So what I would do is see if I would count on.
Forget about the picture. All I have is this number sentence. When am I going to Madison? Yes, there you go. If you don't have a picture and you need to solve a problem like this, we had an exit ticket a while ago. There were no pictures. We had to solve for variables or unknowns. How did we do it? We didn't draw a picture. We skip counted. We skip count by 7. 7, 14, 21, and 28, 35, 35. And then I count 1, 2, 3, 4, 5. What does M equal? M equals 5. But if you had to say which picture better represents what's happening in the problem, is it this, the skip counting, or is it this? Which one better represents the problem, Devon? The tape diagram, because here I see 7 weeks. Here, I don't, I just know the strategy of skip counting will get me to my answer. Does everybody understand that? That's really, really important. Would I take off on a test if you got your answer like this? Probably not. As long as you could explain to me that we need a target sentence, right? How much money does Joey earn each week? As long as you could tell me that M represents what he earns each week. So let's write it, TS. He earns what each week, boys and girls? He earns $5 each week. Okay, so friends at home, that's a really important concept. When we have a word problem, we like to do redraw right so we can represent the problem, so we can see what's happening. These were the 7 weeks. We had to divide the $35 up. We used fair share. Our number sentence was taking 35, dividing it into 7 groups, and the size of each group was 5. We could have gotten our answer 35 divided by 7 equals M by skip counting by 7, but it wouldn't have reflected the problem the way it is written. Okay? All right, nice job, boys and girls. We're going to go ahead and we're going to do some in our workbook now. So, friends at home, I hope you just followed along with a piece of paper. Really important. The more practice we get with these important 2-step problems, the better you'll get, the more confidence you'll have. So we're going to go ahead, and it is lesson 18. And I believe it's page 88, boys and girls. So go ahead and go to page, oh no, actually it's page 95. I lied. Page 95. And we're going to do some together, and then I might let you do the exit ticket on your own. My class did that, and they were pretty good at it. So friends at home, follow along. We're going to do these together. You need to do all the problems on the problem set that we do together here, and then submit them to your teacher. All right? 10, 9, 8, 7, 6, thermometer's right there, so to speak. All right, what do we got going on here? First thing we do is we underline our notes. Go ahead and do that. Instead of waiting for Mrs. Reed. Thank you, Luke.
Wait, is it spring? No, it's not.
Thomas. Always in. Okay, let's read it together so we can get going. Rose has 6 pieces of yarn that are 9 centimeters long. What are you picturing in your head right now? 6 pieces of yarn, right? I think I can draw that if I needed to. 6 pieces of yarn, 9 centimeters each. Sasha gives Rose a piece of yarn. Now, Rose has a total of 81 centimeters of yarn after Sasha gives her that piece. Go ahead and make it quick. We won't get that. What is the length of yarn that Sasha gives Rose? Boy, oh boy, that sounds complicated. So let's start with something easy, all right? After reading our first sentence, about 6 pieces of yarn, and each one is 9 centimeters, what are you wondering? Rose has 6 pieces of yarn and they're 9 centimeters each. What are you wondering? Tommy.
What is the length of the rose?
Rose is a person's name. I think you're almost there. Who can help him out? I think he's on the right track. Lily. My question is, after reading this first sentence, Rose has 6 pieces of yarn that are 9 centimeters long. What are you wondering right now? Ellie. Yeah, how much is all of that yarn all together? Nice job. Okay, so we need to have 6 pieces of yarn. We could draw lines. Hi.
He's absent.
Bruno? Yes. Okay. All right, so we could draw 6 pieces of yarn, but what else could we use that is pretty easy way to represent word problems? Instead of drawing 6 pieces of yarn, what do we use, Ryan? Yeah, let's use a tape diagram. I know Devon likes them too. So I'm going to split my paper down the middle here, and I'm going to draw a tape diagram. And in order to show 6 pieces of yarn, I'm going to make 6 units. If I want to make 6 units, I'll draw 5 lines. 1, 2, 3, 4, 5, 6. How long is each one of those? Go ahead and fill it in. Fill it in and then go ahead and write a number sentence for it. And how about we use the letter C for centimeters? Nice job, Lee. There's our written one. We all decided we would use a C for our unknown. Instead of doing that, why don't we put a 9 inside it? That would be a big times. So if I put a 9 inside each one, see how much quicker that is? You could put 9 circles in there, but that takes a long time, right? See, Kevin, that's a nice shortcut. What number sentence would you write for this picture then, Devon? No. How about 6 times 9 equals C? Why? Because I have 6 pieces of yarn, each one is 9 centimeters. And then go ahead and solve for C. What is C? We have all those tricks. So a lot of you, again, are waiting. Don't wait. Get your answer so most of you wrote 6 times 9 equals C. Mrs. Reed is gonna use the strategy she likes for the 9s. I'm gonna say 1 less than 6 is 5 plus is 9. Bam, there's my answer. C equals 54. So I know she started out with 54 centimeters of yarn, right? Well, and then her friend gives her a piece of yarn, but we don't know how long that is. But we know afterwards she has 81 centimeters. So this is another classic part whole. Because we have a whole that is 81, right? Part of it is what she has to begin with. And part of it is what her friend gives her. 2 parts that make a whole. Well, what do we know? We know 81 is the total she ends up with, right? What other thing do we know? We know... Yeah, but we don't really know how long that is. Fine, what else do we know? Rose is a person's name. Devon. Yeah, and what does it say? That represents what she has. We just calculated what she had, right? Because she had 6 pieces and each one was 9. So that's what she has. What do we have to figure out? How long the piece her friend gives her. We're talking about yarn. Remember, Rose is the girl's name. So, and how about if we use G here for gives? Can you do that? Go ahead and write your number sentence to find G then. Okay, so the number sentence you should have written was 81, which was our total, right? Subtract the one part we know, which was 54, and we will be left with G. Who did the math to figure out what G equals? Kevin. 33. How many people got 33? Okay, so here's the algorithm problem again. So this is what you did with your algorithm. 81 minus 54. So you know how you got 3 here? Because you did 4 minus 1. Because you do not understand the algorithm. Students do not understand the algorithm. It is not 4 minus 1. It's 1 minus 4, and you can't do it, so you have to unbundle. You understand why I don't like the algorithms. I'm going to show you again my way. Alright, people don't like unbundling, so they take shortcuts. They'll say, well, I could do 4 minus 1, so I'm going to put 3 there. I cannot say 1 minus 4, I can't do it, so I'm going to unbundle. My 8 tens become 7, I only have 7 left. But the good news is now I have 11 11 minus 4 is 7. 7 minus 5 is 2. What does G equal? G equals 27. What is the length of yarn that Sasha gives Rose? Yes, the length is 27 centimeters. Don't forget to dress up. Now, can you guys just humor me? I would just like everybody to be on the same page as I am with the algorithm. If I want to find the difference between 81 and 54, I'm going to show you my number line here. 81 minus 54. In other words, I want to know 54 plus what equals 81. So, here's my number line. I'm going to start with what number? I'm going to start with 54. And I've got to add something to get to 81, right? Come on, everybody up here. Ellie, up here. Do not touch those pins. What am I going to add to 54 on my way to 81? What would be the best number to add to 54? Tommy.
54, the best number to add to 54 would be,
I don't think you know. Ryan.
add 6.
Well, let's add 6. Now, why did Ryan add 6? If this doesn't make sense to you, then you got to start asking yourself, why doesn't it make sense to you? He added 6. Does anybody know why he added 6? He didn't just pull that number out of the air. He added 6 on purpose. Why? Kendall. He wanted to make a nice, round, friendly number. And what do you get when you add 6 to 54, honey? 60. Okay, now I'm at 60. I got to get to 81. What could I add next? Lily. Oh, let's add 20. I'm going to make a nice big jump. If I'm at 60 and I got 20, every single one of you can do that. You should all be doing this on your page because the more you do it, the better you'll get it. 60, add 20, what will I be at? Now what am I going to add, Devon?
1.
What did I add? 20 plus 6 plus 1. What's my answer? You know how many people could not do that algorithm and get it correctly? The more you practice this, and the other thing I like about this, boys and girls, it builds good number sense. This does not build good number sense. Okay. All right. I said I wasn't going to do any more of that, but honestly, I just think you guys need to learn how to use the number. Okay, let's look at number 2. We got Julio. Nice job, boys and girls. You're doing great. I think everybody's in for a cotton ball today. Nice math lesson. So friends at home, I hope you got all that. Make sure that if you need to, stop the video, go back and work on your template, and come back, because I want you to have all these numbers here. Next problem, a good student is reading it, and they're underlining their nose. Right, Lily? Are you doing that? Reading it and underlining your nose? So Julio spends 29 minutes doing his spelling homework. He then completes each math problem in 4 minutes. There's 7 math problems. How many minutes does Julio spend on his homework in all? Who can kind of tell me what's going on with this, with no numbers? What's going on in this word problem? Just in general. Just in general. Who? Nope, that's not what I'm saying. What's happening in this word problem? Right. No numbers. No numbers. What's happening in the problem? Ellen. He's doing homework. What? Continue on. He's doing... Okay, so he's got math he's doing. What else is he doing? Kendall. He's doing some spelling. What do we got to figure out? How long it takes him to do it. That's what tells me that you understand a word problem. As soon as you just start throwing out numbers, then it doesn't really tell me that you understand the problem. So, what do we know? We know he spends 29 minutes doing his spelling homework. Let's underline that. And then he completes his math problems in 4 minutes. There are 7 math problems. So, each math problem is taking him 4 minutes. What is our unknown? How many minutes does Julio spend on his homework and all? So you know the question I'm going to ask you with a 2-step problem. What are you wondering right now? I don't want this. Because that's obvious. That's our unknown. You don't want that, but what are you wondering? Well, that's something, but I want to know something before that. What do you want? Nathan. Please track Nathan because everybody could learn. Yeah, what did he say, boys and girls? How long does it take him to do the math? That's what, in boys and girls, I'm not sure you understand how much you can learn from other classmates when you listen to their answers. So we can't figure out how long he spends on his homework until we figure out how long he spends on his math homework. So let's go ahead and figure out how long it takes him to do his math homework. Let's split our paper. What picture could we draw to help us figure out how long it takes him to do his math homework? Luke? Well, probably not a number, and that's going to help us get our answer, but it's not necessarily a good picture. Kendall. Tape diagram, how many units? 7. Why do we want 7 units? You're right. Yes, 7 columns. Let's draw a tape diagram with 7 units. And I'm going to draw 6 lines, and that will give me 7 units. Does everybody see how this represents the math? We got 7 columns. What else can we do with our tape diagram? What else do we know? Hannah? Come on, nobody knows what to do next? What are we going to do next? This is the thing where I feel like if you could just do it independently, but I feel like I have to walk you through every single step. And Ryan and Luke, your hands have been up there. Yours too, Devon. I want to hear from somebody I haven't heard from. Madison. Thank you. We want to put 4 in each one because that's how long it takes him to do each problem. These are our 7 problems. So if I go under here, I can say that this is my 7 problems, right? This is my 4 minutes for each problem. So how long does he spend on his math? We need a number sentence. Go ahead and write a number sentence, and let's use, how about M for minutes? Go ahead and write a number sentence to figure out how many minutes. Please don't do that. Yeah, go ahead and see if we need to do the next word. Write a number sentence for them. We got one in number 1 and one in number sentence. They're still working. We got the right number sentence. So far I've only seen one person who's written the right number sentence. 2 people, very nice. 3 people who've written the right number sentence. Okay, the number sentence we want to write. Well, how many problems are there, Hunter? 7. How long does he take for each one?
4 minutes.
So I have 4 equal groups of, or 7 equal groups of 4, and I'm going to put M. And then M equals, you can skip count, maybe you know the facts. What is M equal? Come on. 28, very good. So now I know, what does 28 represent? It represents the, I'm going to write this right here.
How much he spends on that?
That's his math. Write it. Okay, if he spent 28 minutes on his math, we got to figure out how much he spends on his homework altogether. Come on, that's classic math spelling total. So go ahead and draw it.
That's what we're doing right now.
What numbers am I gonna put in here?
28.
Eden, what will I put into math? 28 minutes of math. What will I put in the spelling?
Question.
Madison. Go back and look at your notes. Underline. Nathan. Hunter. Why did you guys say question mark? He spends 29 minutes doing his spelling homework. Here's your question mark right here. Okay, we're going to use H for homework. Go ahead and write your number sentence. Get that. Those of you who said that you had a question mark in spelling, do you understand why it is not a question mark? It most definitely was one of your notes. 28 plus 29 equals H. What does H equal? You can use the algorithm, okay? As long as you use your code.
I'm gonna do
And then I'm going to show you my mental math strategy for that. What does H equal? Luke. What? 28 plus 29? What does H equal? You added 20. You added 20. Should be 28 and 29. Not sure why you got 26 and 20. Nathan. I got 57 too. I have no idea where you're getting some of the numbers. Are we adding 28, 29? If you need to use the algorithm, that is fine. You just have to understand how to use it. So if I were going to use the algorithm, it'd be 28 plus 29. And I'm not suggesting mental math for those of you who don't understand mental math strategies. 9 and 8 is 17. I have to regroup. 2 plus 1 is 3, plus 2 more is 5. 57 minutes. You know how Mrs. Reed would do this? Number count. This is really close to 30, right? This is really close to 30, right? I would do 30 plus 30 is? And knock off 1, 2, 3. 60 minus 3 is? There's your mental math. Okay, so let's write our number sentence. How many minutes does Julio spend on his homework and all kiosks? He spends 57 minutes on his homework. So friends at home, make sure you're doing all of the steps with the read, draw, write. Underlining your notes, drawing your pictures, writing your number sentences, using a letter for the unknown, doing your algorithms to figure out your answers. Okay, we're just going to do one more, boys and girls. And then I might let you do that after you have your own. My class is awesome. So we're on number 3. So far we've used multiplication, we've used subtraction, we've used addition. But I don't think we've used any division yet, have we? And it did say we would use all 4 operations, so maybe this is the problem. Okay, we're kind of running out of time, so I'm going to read it and underline the notes. And then I want you guys to think about what pictures we can draw, okay? Pearl buys 125 stickers. What are you picturing right now? 125 stickers. She gives 53 stickers to her little sister. What are you picturing? Her giving stickers to her little sister, right? What are you wondering right now? Before we read any further. She buys 125, she gives 53 away. What should everyone in the class be wondering? Devon.
How many does she have left?
Bingo. How many stickers does she have left? It doesn't tell us that. But I think we're probably gonna need to know how many she has left, right? Nice job. Pearl then puts 9 stickers on each page of her album. If she uses all of her remaining stickers, how many pages does Pearl put stickers on? So knowing that we're wondering how many stickers she has left, let's do that part first. So let's split our work area. What picture can we use to represent her having a bunch of stickers and giving some to her sister? And we have to figure out how many she has left. What picture? Thank you, Kevin. Nice job. So let's do part by whole. Nice job. And it makes sense, doesn't it? She has 125 stickers. She gives some away. And she has some up. Nice job, bud. Well, what do we know? Do we know what she gives away, or do we know what she has left? She gives 53, so let's do this. Then go ahead and write your number sentence for that number bond and calculate your answer. Yes. So Kevin just shared, when you have the whole and you're missing a part, that means you're doing subtraction. So my number sentence will be 125 minus 53, and let's use S for stickers. Who has the answer for that? You have that answer, Thomas? Share your answer with your neighbor. Lily, what you got? No, you're not thinking. You're not doing the work. You've got to do the work on the board. Let's go. Pick up your pencil. You're waiting for Mrs. Reed to do it. That's what I would guess. Ellie, what you got? 72. Did you get any other answers besides 72? How many people don't have an answer yet? Looks like Hannah got 72. Hunter got 72. I'm feeling pretty good about 72. All right, 125 minus 53. I'm going to go that you all are correct with 72. If we did our algorithm, 5 minus 3 is 2. 2 minus 5, we can't do it, so one bundle. 12 minus 5 is 72. Okay. So now we know we have 72 stickers, right? She's going to put 9 stickers on each page of her album. And we have to figure out how many pages that's going to take. So go ahead and draw me a picture. How can you show 9 pictures on each page? Right, you want to go 9 pictures on each page. Very easily be able to draw that. You don't know how many pages. Yeah, but you don't know how many you're going to put 9 in each one. So it's kind of a you don't know. You're going to keep counting. You don't care, share? Aren't there 9 stickers on a page? So it's not fair, share, is it? Count on. Count on. Thanks. Okay, we're starting to run out of time. So boys and girls, this is something that should be pretty easy for you to picture. I'm going to draw a page, and I'm going to put 9 stickers on it, right? And if you want to do a tape diagram, you can, but it's got to be a dotted line one because we don't know how many we're going to need. So I'll do another page with 9 stickers on it. What is this strategy we're using? It's not a fair share, it is a count by. Come on, you really know your math, bud. Another 9. 9, 18. Remember what happens with our 1s and our 10s? The 1s go down by 1, the 10s go up by 1. This would be 36. Another 9 will be 45. Another 9 will be 54. I got to keep going until I get to 72, right? Another 9 will be 63, and another 9 will be finally. Right? So how many pages does she need? Kevin?
8 pages.
8 pages. This is a page. The 9 is how many stickers are on it. So 1, 2, 3, 4, 5, 6, 7, 8 pages. Biggest question, what number set you gonna write for that? Think about what we knew. And we're gonna use P for the number of pages. So we use P for our unknown. Lily? Nice job, girl. How many people are going to say that? What did we know? We knew there were 72 total stickers. We knew 9 went on a page. We take 72 and divide it into groups of 9. P will equal 8. Nice job, boys and girls. Come on. How many think these are a little bit fun? They're a little bit like a puzzle, aren't they? So how many pages does Pearl put stickers on? Yes. Let's just say she uses, what class? She uses 8. Make sure you do all that. Do you understand, Kevin, how 72 can't be the number of pages? 72 is the number of stickers. 9 is the number of stickers on a page. You gotta understand your picture. Got it? Nice job, boys and girls. My class did the exit ticket, but we don't have time, so I might have you guys do the exit ticket on Tuesday. Have a great long weekend, everybody. I think we're gonna get a lot of snow on Sunday night into Monday, so you might be able to play outside all day on Monday in the snow. And go Bills! Go Bills!